Assalamu alaikum kids. So this right here we are discussing May June 2016. All right, let's begin. Student investigates supporting ठीक है or explain why this is not the best way to assemble one stand boss clamp to support a heavy rod. Uh, stand is the opposite direction. Stand is the opposite direction and stand जो है वो opposite direction में है, clamp जो है वो opposite direction में है. So of course that's going to make your stand very unstable. So hence not a good idea. Okay. So we can just say the stand will be unstable in this position. All right, in the space to the right, sketch a better way of assembling this apparatus. ठीक है, तो आपके पास जो है वो stand and then you've got your rod and rod को थोड़ा सा लंबा बना देंगे and then you've got your clamp in this direction right here. So it does not necessarily have to be a very accurate diagram, but essentially what you need to suggest that the clamp and the stand should both be in the same direction essentially. ठीक है. Two clamps, blah blah blah. Students given a meter rule and two set squares to check the rod is horizontal. Draw figure 1 to show how the apparatus is used. Interesting. So, this right here could be done in a multitude of ways. One of which I can think of is, okay, of course, you're going to put your meter rule like this. Okay, meter rule ko jo hai, we are going to try and keep as vertical as possible. Of course, you cannot keep it vertical, exactly vertical. Okay, rather. So in that case, essentially what we are going to do is we are going to use a set square, okay, to make sure that it's vertical with the bench. And you are going to do that on the opposite side as well. यहाँ पे भी जो है वो आप exactly यही काम करेंगे. Again, drawing set square on the left or the right doesn't really matter. Maybe you can use the second set square to make sure that it's aligned with the rod as well. Okay. So if it's completely aligned with the rod, we can say कि अच्छा ठीक है, this right here is horizontal on all sides essentially. On the other hand, आप ये भी कह सकते हो कि यार you're going to use the second set square on the front or at the back to make sure कि वो horizontally तो okay it's so your meter rule can move two ways. So it can move left or right, or it can tilt towards the front, or it can tilt towards the back as well. Okay. So in that case, you'll have the second set square behind or in front to make sure that it's vertical that way. Okay. जाहिर सी बात है, inshallah when we have the studio set up, so I'll be better able to give a demonstration of how that works exactly. Explain how we can tell the rod is horizontal, same height. On opposite ends कर देते हैं, but it does not necessarily have to be on the opposite ends. मतलब we can take a couple of readings, एक यहाँ पे reading ले ली, एक यहाँ पे reading ले ली. If both the readings are the same, then of course it's going to be horizontal. ठीक है. So, Rod, describe how the student can check that end A of the meter rule is exactly above 0 centimeters. Again, we can put a set square and check. ठीक है. आप एक सेट स्क्वायर लगा के चेक कर सकते हैं. आप एक यहाँ से प्लम लाइन जो है वो सस्पेंड करके जो है वो चेक कर सकते हैं. सो you could go with either a set square, use of a set square, or plumb line. ठीक है. अच्छा, the meter rule is moved, blah blah blah, calculate average. Okay, so that's going to be 250 plus 8, 258, 260, 264. 264 divided by, there are 5 readings. So that's going to be 52.8. Again, I'm doing that without a calculator. मेरे ख्याल में आपको कैलकुलेटर से जो है वो कंफर्म कर लेना चाहिए. ठीक है. So the n average will be क्या कहते हैं 52.8. Give your answer to two significant figures. So of course 52.8 would not be the correct answer. कह रहा है कि 2 SF पे देना है तो 53 would be. Student uses stack, repeats, he then cuts. ठीक है. Figure 1.5. Recording NAV from C2 for L0. तो NAV हमने 53 लिया था because again all of them are correct to the unit digits. ठीक है. So we are not going to go with 52.8. We are still going to go with 53 over here. On plot the graph L against NAV. L on the y-axis, NAV on the x-axis. So of course I'm gonna have to take a screenshot over here. अच्छा जी. Let's see. Okay. Interesting. ठीक है. So L goes from 0 to 19 and N goes from 3 to 53. So I'm pretty much gonna draw it from the origin, and it says it's going to be from the origin and it's going to be a smooth curve of best fit. Okay, so let's go with that. 19 and 3. So पहले ग्राफ की तरफ आ जाते हैं. On the x-axis you have, all right, so NAV 0 to 53 has to be on the x-axis. So I'm pretty sure I don't have any choice but to use 10 units. 30, 40, 50 and 60. Comfortably I can use the scale. On the y-axis I need to go from 0 to 19. So maybe there are like 10ish divisions. 1, 2, 3, 4, 5, and then you've got 6, 7, 8, 9, 10 and 11. तो अगर 11 डिविजन्स में मुझे 19 को डिवाइड करना है तो आई एम स्टिल गोना गो विद 2 units a division. That goes all the way till 22, but that suffices the condition that you have to use more than half of your graph. So I'm gonna go with 2, 4, 6, 8, 10. Then we've got 12, 14, 16, 18 and 20. That should be it. Okay, and maybe 22 over here. All right, my values are what? My values are 19, 3, 15 and 6. So 19 would be over here. 19 and 3. 15 is gonna be over here. 15 and 6. All right, 11, 12, 7, 22. 11 and 12. So this right here is 11 and 12. And then we have क्या था? 7, 22, 3, 35. Then we've got a 7, which is gonna be over here. 7 and 22. 3 and 6. 3 and क्या था? 35. 3 and 35. 3 is gonna be over here. 35. So 1, 2, 3, 35. And then 0 and 53. So this right here is my graph. Okay, so this right here is a long one. So this right here should what my curve of best fit should approximately look like. Zahir si baat hai, you should be able to draw it on a paper much better. Take care, but for our intents and purposes, this should serve just well. Um, yeah. So going back to this. Plot कर लिया हमने. The graph shows that as L increases, NAV increase. As L decreases, NAV increases. Two quantities X and Y by taking two pairs. NAV is not inversely proportional. So K must be equals to X into Y. So any 2 points other than the points already mentioned, if I take those, then the product should essentially be different. Okay, so let's try and take 2 exact points. So let's take this one right here. ठीक है, 2 exact points आ गए. So this right here is going to be 16.6, and on x-axis this seems like it's going to be a 5. So a 5 and a 16.6. ठीक है. So what is my product? 5 times 5 times 16.6 is going to be 83, if I'm not wrong. 5 times 16, that's 80. 5 times 0.6, that's 3. So 80.83, my bad. So this right here is going to be 83.0. And let's take another point. Maybe another exact point that I can get is this right here. This right here would be a 4 and a 32. All right. So 4 and 32 है. इसका product 4 times 32 would then be equals to 128. All right. So of course, because the product is different, your curve or your quantities are essentially not क्या कहते हैं, not inversely proportional. So we can say product not equal, hence not inversely proportional. Apologies in advance for any incorrect spelling. Basically, the habit's been ruined by autocorrect when texting or WhatsApp messages, stuff like that. But khair, this is not an English paper, so spelling errors are taken again. They don't really matter. Suggest why student starts with L19, then reduces L rather than start with 3 and increases L. I'm guessing because it says you need to cut the card. Zahir si baat hai, let's say for example, if you start with a 3 and you cannot cut your way into a greater length. If you start with 19, that you can cut this down and eventually get to 3 as well. So larger, so we can say that larger length can be cut down as only one card provided. The question says over here that you just have one card, if I'm not wrong. कहीं ना कहीं होगा. यहाँ पे I remember reading that you are given just one card. So far I don't see. Student measures is given one square piece of card. So let's say for example, if you start with a 3, you will need multiple cards. Right now you can just work with one if you start with 19. One card provided. Starting with 3 would require more than one card. ठीक है जी. All right. That's that. Continued. Okay, so this right here. So that was question number 1. Question number 2 says student investigates path of ray, blah, blah, blah. On figure 2.1, mark and label the midpoint of the side AB of the prism. So, student path of ray light through a triangle on figure page 7 shows the triangular prism placed in the center of the sheet of a white paper. Okay, ठीक है. The midpoint of AB of the prism. Midpoint के लिए you'll of course need क्या कहते हैं, a ruler. I don't have one, so I'm just gonna eyeball this. So maybe this right here is the midpoint. Yeah, pretty much seems like that. Midpoint label kar diya. Draw the normal to the prism at P. So this right here is point P. And again, I'm gonna have to eyeball the normal as well. So my normal must look 90 degrees, so something like this. अच्छा जी, normal भी बन गई. Draw a line to represent a ray of light incident at P with an angle of incidence of 40 degrees. Okay, so you need a line that's incident at 40 degrees. So maybe 40 degrees is like so. Yeah, 40 degrees ho gaya. Then we have draws a ray that produces a narrow light. Describe how the student can use the narrow ray of light to find the path of the ray through the prism. Okay, so essentially what we can do is the pins method. All right, you can use the pins method. You can do what? You can essentially क्या कहते हैं, so if you haven't watched that video, I'll probably post the link in the description. तो आप वो वीडियो ज़रूर देख लीजिएगा. I'll post it on the group as well. So essentially what you'll do is you have the incident ray over here. The ray box is going to be placed over here, and then what you're going to do is you're going to observe the ray of light from here. All right, so essentially what's going to happen, you're going from air to glass, so it's going to move, sorry, you're going from air to glass, so it's going to move towards a normal. So maybe the angle of refraction is not going to be, it's going to be less than 40. So maybe it goes something like this, less than 40. And this right here is the normal. So in that case, now it's going from more dense to less dense. So this right here is going to move away from the normal. So like so. Okay, so I in the wrong place. So your eye should be placed somewhere over here. Okay. And essentially what you're going to do is you place the ray box as shown. You observe the ray from the other side, and then you place pins right behind each other, at least 5 to 6 centimeters away from each other. You need to make sure that the pins are placed vertically, and you observe the pins. This right here is the emerging ray. ठीक है, you draw the emerging ray, and ये आपने emerging ray जो है वो बना दी. So you see कि अच्छा ठीक है, this point right here is where the emerging ray emerges, and then you connect these 2 points to get the path of the ray inside the prism. अब यहाँ जाहिर सी बात है, यहाँ पे you need to make sure that, so again this is a process that we probably have discussed in class before. So what are you going to do? Place fine, ठीक है. So place ray box, observe ray from other side. You can name the other side. The other side from which we can observe the emerging ray is BC. So yeah, other side you can BC. ठीक है. Stack pins. Yeah, insert pins in the paper at least 5 centimeters away from each other. Acha, sorry, I forgot one thing. Draw an outline of the prism. So that's important. So then you remove prism slash pins, draw line connecting pins. I'm just being, Zahir si baat hai, this is 4 points, so you require 4 points here. I'm just being cautious not to miss any important point over here. That's why I'm writing more than 4. Just being cautious to make sure that I don't miss any integral point. Um, um, Join point P and the point where the ray emerges. इसको हम कह देते हैं point Q. So ये वाला जो point होगा where your ray emerges, this point right here is going to be point Q. You can say draw line connecting pins, mark Q where it reaches BC, and then join PQ, and PQ is going to give you the path of the emerging ray. Essentially, that's the idea. All right, and yeah, that's pretty much what it is. Let's see. Okay, moving on to the next question. Group of student measures forces using set of bathroom scales, blah blah blah. State the weight of the student. That's acha newtons mein hai. So each division is going to be 20. So you should see a 540 newtons. ठीक है. 540 exact होना चाहिए, of course. Explain why a student needs to stand still on the scale. So of course, again, at some point, everyone has weighed themselves. So whenever you move, your reading changes as well. So reading changes if a person moves. All right, explain why it is if the student takes the reading directly above the scale to avoid parallax error, of course. I hope that's the correct spelling of parallax. So said. Two students use scales to measure maximum friction force between a bench and a heavy box. One student places scales against the side of the box. ठीक है. As shown, he pushes the scales with both hands, and the other student notes the reading on the scale when the box just starts to move. Explain why it is important the student pushing the box increases the force slowly. Oh, जाहिर सी बात है, अगर if the student does not push slowly or increase the force slowly, you won't be able to get the correct point where the box will actually start to move. So जाहिर सी बात है, you're going to say कि to accurately measure force where box moves. यहाँ पे explain क्योंकि करना है, तो it's better to say if force applied quickly force value might be larger than actual value, because of course your force reading is going to overshoot essentially. Okay, so there where a student places the box near the edge of the bench. All right. तो जाहिर सी बात है, अगर बेंच के बहुत ज़्यादा आगे की तरफ होगा तो pushing it would be a little awkward. The positioning would be a little awkward. तो हम लिख देते हैं टू इजीली अप्लाई फोर्स. अब एक्सप्लेन कर देते हैं कि easier to reach near the edge. सही है ना. So of course when it's going to be closer to the edge it's just going to be easier to push. मतलब it's going to be more reachable. It won't be an awkward position for the student. ठीक है. Alright, moving on. Question number 4. Question number 4 says what? Blah blah blah. To send a second large reel that's used to hold ribbon. The cylinder has a diameter of 3. One student uses a ruler and apparatus, and for finding the diameter, the distance between points A B changes as the screw is turned. What's A and what's B? Use different to find the diameter of the central cylinder. Take care. One student uses a ruler and the apparatus shown. Okay, describe how the student measures the diameter. So place place AB in this position. So A यहाँ पर आ जाएगा, B यहाँ पर आ जाएगा. You now, जाहिर सी बात है, because this is screwed, so you can fix points A, B on either side of the central cylinder. So fix point A, B and B on either side of cylinder. You, because आपने mark किया हुआ होगा, you can write as shown in 4.1 and measure length of AB. ठीक है. So that's what we can do. The other student measures the only following apparatus: meter rule, pencil, blue tack, 1 meter of thin thread. Describe clearly how she can find an accurate value for the diameter. Given that you have a thread, so the correct method would be to wind the thread around the cylinder several times. Not one, because again one will not be accurate. हम pendulum swing करते हैं, वो भी multiple times. So we swing pendulum 10-20 times. We did a question earlier. The question number 1, there were 50 odd oscillations and so. इससे पहले, if I'm not wrong, in the last paper as well, we did some timed swinging pendulum thingy. So what we can do is we can maybe wind it around or wrap it around the central cylinder several times. So wind, wrap, again, whatever word, as long as you can clearly communicate the idea. Wind the thread on the cylinder. Of course, you are going to count how many times. Okay, usually 10 is enough. 10 times कर देते हैं इसको. ठीक है. And then we can say, okay, all right, measure the length of the thread. सही है. Measure the length of the thread. And then we can say, okay, divide by 10. Divide by 10. ठीक है. And then we can say equate with 2 pi r कह लें, pi d कह लें, एक ही बात है. क्योंकि अब because we wound it around 10 times, that's 10 times the circumference of the central cylinder. So hence we need to divide by 10, and then we can say, okay, you can equate with pi d or something along that line. ठीक है. That's that. Blank page. So no more questions. ठीक है बच्चास, ये जो है ये आपका. So this right here was May June 2016. ठीक है. I hope that everything made sense. नागिन अभी रात के तकरीबन कोई 2 बज रहे हैं, सो अगर कोई चीज़ समझ में ना आई हो, और इफ़ आई वेंट ओवर समथिंग वेरी क्विकली, so please mention that on the comments. And if you have any questions, you can get my number from the description. You can ask me. कोई भी चीज़ हो, please feel free to contact me. All right. Inshallah, I'll see you in the next one. Bars out.